Hello everyone, I am Ümit Alkuş. In this video, we will solve one problem in chapter 8. For the pendulum shown in the figure, we are given M as 720 grams and L as 76 centimeters. The bob is initially held rest at this position and then it is released. Calculate the magnitude of the tensional force when the bob is at its lowest position. Before solving the problem, let us draw the free body diagram of the bob when it is at its lowest position. We choose the appropriate coordinate axis. We represent the mass by a big dot. After that, we draw all the forces acting on the bob. The gravitational force acting on the bob is a downward force of magnitude m times g. The tensional force acting on the body is an upward force of magnitude t. The motion of the pendulum can be regarded as the uniform circular motion. Therefore, the centripetal or radial acceleration vector of magnitude v squared over L has to be drawn upward along the string. Okay, that's all about the free body diagram. We can write the equation of motion with the help of the Newton's second law of F net equals ma. The equation of motion along the y-axis when the bob is at its lowest position can be regarded as the centripetal motion. Therefore, the centripetal force becomes T minus m times g, which has to be equal to m times v squared over L. The conservation of total energy can be written as the following. The sum of the initial potential and kinetic energies is equal to the sum of the final potential and kinetic energies. If we take the bob's lowest position as a zero gravitational potential energy, the initial potential energy can be written as m times g times h. Because the bob is initially held rest, its initial kinetic energy is zero. The final potential energy of the bob is zero. And the final kinetic energy is equal to the 1 over 2 times m times v squared. As a result, the conservation of total energy can be written as m times g times h equals 1 over 2 times m times v squared. From which we obtain an expression for m times v squared as 2m times g times h. If we substitute this expression into equation 1, we get t minus m times g equals 2m times g times h over L. From the figure, we know that h equals L times 1 minus cosine theta. L's are cancelled, then we obtain 2 times m times g times 1 minus cosine theta. If we expand this expression, we obtain 2mg minus 2mg times cosine theta. If we take the negative m times g at the left-hand side to the right-hand side, simply we have 3mg minus 2mg times cosine theta. Finally, t equals mg times 3 minus 2 times cosine theta. Now we can put the numerical values into this equation. Finally, we find the magnitude of the tensional force when the bob is at its lowest position as approximately 9.9 newtons. This result brings us to the end of the discussion of this problem. Thank you for your attention. See you in the next video.